Boiling and melting points. By Decroly Education Center. Boiling. Boiling is the process by which a liquid changes its state to vapor at a specific constant temperature. For pure water, this temperature is 100 degrees Celsius. This temperature is known as boiling point, and when it is reached, vaporization occurs throughout the body of the liquid, not just from the surface. Bubbles of vapor from throughout the body of the liquid rise to the surface and burst, releasing the vapor to the atmosphere. A simple method of determining the boiling point of a liquid, not flammable liquids, is described in the experiment below. Experiment 2.7, the boiling point of liquids. Aim, to determine the boiling point of water. Materials required: distilled water, hard test tube, boiling test tube, or a round-bottomed flask, rubber cork with 2 bores, delivery tube, iron stand with clamp, pieces of pumice stones, 250 milliliter beaker, thermometer. Procedure. Take about 70 to 100 milliliters of fresh, distilled water, not hard water, which contains extra salts, in a round-bottomed flask, and add 2 to 3 small pieces of pumice stone. Fix a cork with 2 bores in the mouth of the boiling flask and clamp it with the stand. Introduce a thermometer in one bore of the rubber cork of the flask and a delivery tube in the second bore. Keep the bulb of the thermometer above about 3 to 5 centimeters from the surface of the water. Apparatus for boiling point determination. Place the beaker below the second end of the delivery tube to collect the condensed water. Heat the flask gently, preferably by rotating the flame. Note the temperature when boiling of water starts. Continue to heat so that the water remains boiling. Note the constant temperature. Record your observations in tabular form. Repeat the experiment 3 times. Readings. Mean value. Starts boiling, temperature T1, in degrees C. Continues to boil, temperature T2, in degrees C. Readings. Mean value. Starts boiling, temperature T1, in degrees C. Continues to boil, temperature T2, in degrees C. Observations. Record your observations in a table as given below. Inference. The boiling point of water is 100 degrees Celsius. Precautions. The bulb of the thermometer should be kept about 3 to 5 centimeters above the surface of the liquid, water. Pieces of pumice stone should be added to water before heating to avoid bumping. Heating of water should be done by rotating the flame. Note temperature by keeping your eyes in line with the level of mercury. If you start recording the temperature from the time when ice start melting, the results from the table above can be used to make a boiling curve, which will look like this. Is the temperature at which a liquid changes its state to gas, and it is the boiling point. Note, evaporation, unlike boiling, can happen at any temperature, but only at the surface of the liquid. Boiling and evaporation compared. Factors affecting the boiling point. Factors affecting the boiling point. Impurities. Experiment 2.8, the effect of impurities on the boiling point. Aim, to demonstrate the effect of impurities on the boiling point. Apparatus, clamp and stand, beaker, tablespoon, thermometer, distilled water, salt, Bunsen burner, tripod stand. Procedure. Set up the apparatus as shown in the figure below. Add some salt to boiling water, and record the boiling point of the salt solution. Determination of the effect of impurities on boiling point. Observation. After you carry out this experiment, you will find that the boiling point of water can be changed by the presence of impurities. Explanation. When salt is added to boiling water, the boiling point is raised. A soup boils at well above 100 degrees Celsius because it contains too many impurities. The presence of dissolved impurities in a liquid affects boiling point. The nature of the impurities determines whether the boiling point of the liquid is raised or lowered. Pressure. Pressure. Pressure affects the boiling point of a liquid in that, as external pressure increases, the boiling point of a liquid rises. When the pressure is lowered, the boiling point is also lowered. This can be demonstrated in the experiment presented below. Experiment 2.9, Effect of pressure on the boiling point of water. Aim, to demonstrate the effect of pressure on boiling point. Materials required, clamp and stand, lab thermometer, source of heat, rubber tube with clip, water, round-bottomed flask. Procedure. Set up apparatus as shown and then heat the water in the round-bottom flask till it starts boiling. Water boils at a lower temperature when the pressure is reduced. By pressing the clip on the rubber tube, allow the steam to escape out of the flask. Observation. You will notice that the thermometer reads 100 degrees Celsius. But if you trap the steam inside the flask, the temperature of boiling water will start increasing. This is because by increasing the pressure, boiling point also increases. Now invert the flask and pour cold water on the top of it to condense the steam. In this case you will notice that the water starts boiling at a low temperature below 100 degrees Celsius under a low pressure. Inference. As one goes higher, the atmospheric pressure decreases. At about 300 meters above sea level, water boils at 90 degrees Celsius. Certain pulses, pod grains, cannot be properly cooked in the open in very high regions as the boiling point of water in these places is too low. These pulses can be easily cooked with the help of a pressure cooker. The water in the pressure cooker boils at a very high temperature, nearly 120 degrees Celsius, as the pressure is increased to 2 atmospheres. Thus the food cooked in water boiling at a high temperature takes less time than that at 100 degrees Celsius. Melting. This is the process by which a solid changes its state from solid to liquid at a specific constant temperature. For pure water, ice, this temperature is 0 degrees Celsius. This temperature is known as the melting point of the solid. When the melting point is reached, no matter how much heat is added, the temperature does not change until all the solid has melted. The melting point of a solid can be determined using the experiment below. Experiment 2.10, Melting point of solids. Aim, to determine the melting point of ice. Materials required, tripod stand, Bunsen burner, 250 milliliter beaker, stirrer, ice cubes, thermometer, wire gauze, stand with clamp. The procedure. Take some ice cubes and dry them using a filter paper and quickly put them in a beaker. Place the beaker over a wire gauze kept over a tripod stand. Suspend a thermometer, temperature range -10 to 110 degrees Celsius, with the help of a clamp stand so that its bulb remains in the middle of the ice cubes. Ice cubes are moderately heated by a gas burner and stirred continuously using a glass rod. Note the temperature, T1, when the ice starts melting. Continue heating the ice. Note the temperature, T2, when the ice has melted completely. Record your observations in tabular form. Observations. Record your observations in the table given below. Temperature when the ice. Melting point of ice. Starts melting T1, degree C. Completely melted T2, degree C. Temperature when the ice. Melting point of ice. Starts melting T1, degree C. Completely melted T2, degree C. Inference. The melting point of ice equals 0 degrees Celsius. Precautions. The bulb of the thermometer should be kept surrounded with ice cubes. Ice should be stirred regularly to keep a uniform temperature throughout. Note temperature by keeping your eyes in line with the level of mercury. If you start recording the temperature from the time when ice start melting and continue recording after all ice has melted, the melting curve can be drawn from the results in the table above and looks like the following. Change of state from solid to liquid. Tm is the temperature at which the solid changes its state to liquid. It is also the melting point of the solid. Factors affecting the melting point. Pressure. For most solids, an increase in pressure raises the melting point. However, this is not the case with ice, solid water, since it contracts on melting. When pressure is increased, melting is encouraged and as such the melting point is lowered. Impurities. The effect of impurities of the melting point is demonstrated by the following experiment. Experiment 2.11, the effect of impurities on the melting point. Aim, to demonstrate the effect of impurities on the melting point. Apparatus, pure ice blocks, big beaker, laboratory thermometer, table salt, clamp and stand. Procedure. Put the crushed ice in a big beaker. Plunge the bulb of the lab thermometer in the middle of crushed ice and record the melting point of the pure ice. Add some salt in the ice and now see the melting point of the ice-salt mixture. Demonstration of the effect of impurities on the melting point. Observation. After you carry out this experiment, you will find that the melting point of water can be changed by the presence of impurities. Explanation. When salt is added to ice, the melting temperature can fall to as low as -20 degrees Celsius. The salt lowers the melting point, causing the ice to melt. In cold countries, salt or sea sand are spread on the road surface to melt the snow, otherwise the icy road would be too slippery for cars to drive on. Salt, or sea sand, are spread on the road surface to melt the snow. The presence of impurities in solids lowers the melting point of a solid. Thanks for your attention. Kindly like and share our videos. Please don't forget to subscribe and press the notification bell to be the first to receive the next learning video. You may also give us a comment to suggest what topic you would like us to cover. See you later.